Well, thanks, guys. It's nice to meet you. My name's Andrew Scaglione. I'm with Radio Cloud, based in Cleveland, Ohio. Unnaturally sunny, so if I'm like shadowed against the window, we don't get very many sunny days here in Cleveland. So I'm trying to bask in it while we can. But I appreciate Kent for reaching out to me and setting up me as the presenter for this January meeting. So I hope you guys are doing well. What I'm going to do today is give you just a little overview on where we are as an industry in terms of cloud technology, AI technology, which is a fun conversation because that's just a constantly evolving topic. And then I'll give you some case studies as to how those two topics are being applied by companies like us with some of our clients, just to kind of paint that in a different perspective. So I have a deck. Halfway through the deck, I'll switch the screen share and show you just a little bit of what the platform looks like, and then go back to the deck, and we can kind of dive deeper into anything you guys want at the end, question wise or case study wise. So I'll share my screen and I'll get started. What are you guys eating today? Barbecue?
Oh yeah. Well, we're in a barbecue place. It's hard not to get it.
Nice. Love
But
me
thanks.
some good barbecue. Yeah, no, absolutely happy to provide. We don't get a lot of good barbecue in Cleveland, but my wife is from Kansas City, so I do.
There we
Every time we go back there, we get some good ones. Let me make this full screen. Make sure we can all still see it. Can you guys still see that on the screen share?
go. Oh yeah.
Yes.
Okay, excellent. So let me make sure I can see everyone. Okay, perfect. Yeah, so I'll start with cloud and then we'll dive into AI in a few minutes. But what I want to define first is cloud native, because there is a difference between just being in the cloud, being cloud based, and then being cloud native. And our software is cloud native. And what that means is it was built from the ground up in a cloud environment. So right from the get-go, everything was developed and built for the cloud rather than taking an existing, terrestrial based software and hosting it on a virtual machine or moving aspects of it up into the cloud. And the reason we did that and the reason other companies do that is it's just you get to take advantage of more of those cloud-based features and the efficiency and the functionality than you would by taking something and shifting it into the cloud. One of our partners is Amazon Web Services. They call that other method lift and shift versus this, which is just building something in the cloud. We hear the term microservices thrown around a lot. Just an example of a microservice in our world would be generating a playlist, transcoding an audio file, things like that. So those microservices run in containers. And with a cloud native architecture, the containers are really scalable, meaning you can kind of flip them on and off as you need when you need them. So there's not anything running constantly in the background. It's if I need to transcode this audio file, that container comes on, a couple milliseconds later, it's off, and then I just use it again when I need it. The real benefit to cloud native architectures and setups is the money you can save on the capital expenses for hardware and even some on the operating expenses side as well. We'll dive into that a little bit later. But I think it's always nice to start off with kind of a comparison between your traditional automation and playout systems and then what a cloud driven system like Radio Cloud, just the differences between them to sort of set the landscape. So, like I sort of just mentioned, you have those initial hardware and software costs, which, as we all know, we've worked with Wide Orbit, we've worked with Enco, Zeta, Audio Vault, you name it. It is that expensive initial buyout. And then you own the software, but then in 5 or 10 years, when you want to upgrade, you have to go through the buyout again. Whereas with Radio Cloud, you always have the latest version of the software. You can save up to 90% on the hardware. And something I'll touch on towards the end of the presentation today is sustainability, which is something that we take seriously. And the lesser hardware footprint sort of helps us play into that. On a traditional system, you have the repetitive manual updates that you have to do to the software, even if it's just a hardware machine that you own, whether it's Windows or something else, you update that manually. Everything in Radio Cloud and other cloud native softwares, it's nice because you can just push those automatic updates or new features or improvements right through the cloud, no downtime, nothing that you on the local end have to do manually. So it saves you a little time. It's always been possible, but cumbersome and maybe getting easier and more in recent years. But to connect different clusters or stations in different locations and to sort of network them together, content sharing, voice tracking for one station in a different market, things like that. It has been getting easier, but it's just so easy through the cloud because I could be sitting in Cleveland, Ohio, doing voice tracks or a live show even for a station in Portland. And all I have to do is log in through my web browser. I don't need a VM or a VPN or any other layers of technology beside my computer and a microphone. Localization is something that our technology specifically is we kind of pride ourselves on, but in a traditional sense, localization's always been possible. It's just a little, I'll use that word cumbersome again to do, especially across multiple locations. You can get up to 5 times more localization per hour with a cloud-based technology like Radio Cloud. And then the last one would be more complex features. Typically, just you kind of have to keep provisioning the hardware because it just gets more, you need a stronger machine sometimes to run these as the automation playout systems develop and get more feature rich. Whereas a lot of what's running with Radio Cloud is running in the cloud in AWS, whose infrastructure we're taking big advantage of. And so because of that, it's just a lot less on-site hardware, a lot less on-site, CPU power needed essentially. So with all that in mind, take you through a few case studies of some of our clients. I see there's a message in the chat. Just want to check that quickly. All right. So one of the case studies I like to talk about is our news talk station down in the Houston market, KYST. It's 24-hour satellite driven news talk station. And the real benefit of that they saw from using a cloud native system like Radio Cloud was last July. Hurricane Beryl came through the area. That was one of there was a couple bad hurricanes last summer. That was one of the first ones, hit the Gulf, hit Houston. Their station lost power for a week. They couldn't even get into their station for a week. But they had the Radio Cloud playout box out at their transmitter site. Their transmitter site didn't lose power. It was okay. And because of that, the station was one of two news talkers in the market to stay on air the full time during the aftermath and the storm itself. So they could serve their listeners without actually going into their station, do everything remotely for the live hours and for the pre-recorded satellite hours. And so when I say the Radio Cloud playout box, I'll show you what that looks like now. This is probably as good a time as any to do it. And so what we do is everything's done in the cloud, but because we still feel like it's important to have that on-site redundancy, to have that play out ability in sort of any circumstance. It may not be this exact model, but we usually send something like this, a tiny little fanless server, fits in the palm of your hand. We've sent 1RUs before as well. But essentially, it's a Windows machine. It's a playout. It's a simple Windows machine with a playout on it. And it does the playout from either the station or the transmitter, wherever you mount this thing. The benefit of that being it stores forward up to 2 weeks worth of your logs and content. So if the internet goes down, you stay on the air. There's no interruptions. It's not like we're sending a signal from the cloud directly to the transmitter or a stream. It's actually the high quality uncompressed audio playing out from that box on site. So when this station in Houston came on with us, they said, well, can we put everything out at the transmitter with our satellite receivers, our uplink, our dish? And we said, yeah, and you should do that because that's, it's going to be connected to the satellite receivers anyway. So put it out at the transmitter. And then it just happened to, 5-6 months later, hurricane comes through and that setup that they had was really beneficial. Another one that we have down in the Bay Area, it's a cluster of 4 stations, an FM and a few HD stations, and they had those HD stations on air with Radio Cloud, but then their landlord comes and says end of the month, you have to be out of the building. And this was in August last year. So that's always fun trying to figure that out. But because of Radio Cloud, they were able to take essentially their backup box, go put it at the transmitter. We flipped all the playouts to that box so they stayed on the air. Then they moved their main box out to the transmitter site. And the few other important pieces of hardware they had that they needed to save, they also shifted out there. Everything else you can see in the picture. They sent this to me at the end of August as they were moving out of the building. They wiped out, it was 4 or 5, or it might have even been 6 just racks of equipment. Some of that's at the transmitter. A lot of that now was made obsolete. They were able to downsize into a non-traditional radio space, but get something much more kind of like on a main street in the community that they serve. So more visibility, less space, and saving money all the while. Some of you may have heard of WEPN, which is 98.7 in New York. Last August into September, flipped formats, and then again last week it flipped formats. So last August, they approached us and they said, we're taking this back over essentially from Emmis. Emmis is leasing this to us to program. Can you get this station on the air if we went with Radio Cloud within, essentially it was 2 weeks, but really it took about 5 days. And that's just something that's not really possible with a traditional setup because we didn't have anyone in New York. The station itself actually didn't have anyone in New York. The program director is in Cleveland. The morning show was in Delaware. And the engineer was a contract engineer, but he was in Jersey. So he was able to go into New York, but he wasn't based out of a station or a studio or anything. So basically what we did was we sent them a couple of these boxes. He goes and mounts them at the transmitter, which is fun to talk about because it's the Empire State Building. And then they did everything else remotely. And that's just not really possible without a cloud system, especially not possible in that accelerated of a timeline in a week or two to get a full station on the air. Or what just happened over the holidays, essentially a week and a half to 2 weeks to completely flip the format and train a new staff that was coming in to program the station. Again, completely remotely, kept all the same hardware in place though. So it's just things like that that let you do different things and opens up the world of possibilities when you don't have to be tied down to a studio and you don't have to buy all this expensive hardware to get something up and running. I think one of the case studies that paints the best picture of the power of the cloud in radio, we have a product which is used heavily in Europe called News Cloud. It's essentially a browser-based news production, localization, and distribution hub. But the engine driving that is Amazon Web Services and those cloud features and functions that I've been mentioning. What this service does is we serve about 150 different stations around, this is in Germany, and there's a news organization that comes in here, produces different stories every hour, and then sends them out to their various clients. There's about 130 versions of the news produced for those 150 clients. And it's, national story, regional story, state story, another national story, sports or weather. There's probably 25 to 30 work parts produced every hour, or that's the kind of pool that they have to choose from. Every station says, this is the order of stories I want. It's a preset, basically file or preset sort of, a multi-track session without it being a multi-track session. But what we used to do was they would produce it up to 10 minutes before the hour, and then it would take about 7 to 8 minutes with the cloud to splice everything together and automatically distribute it. Now we've moved this to something called AWS Lambda. And Lambda is a super cool technology I'll talk about more on the next slide. But what it allows us to do is basically render and distribute all 130 versions to 150 stations in 7 to 8 seconds. So now the news production crew at this network can work up until 56, 57, even 58, like 2 minutes before the top of the hour, and still get those updated newscasts out to their clients within a matter of seconds. And so the common factor in all of those case studies, as I've mentioned, AWS, we're an official partner of theirs, so we get to take advantage of a lot of those cloud features. Lambda is my favorite one to talk about. It's probably the one we use the most. And in its simplest fashion, it's just serverless computing. So right now, to do a lot of what I just showed on site at a small, mom and pop station or a little medium-sized cluster, anything on site, you'd need a lot of computing power to do that. And it would be something that would kind of always be running in the background, ready to serve that purpose. With Lambda, basically what we're doing is renting that server from an AWS data center, and really in your region, but anywhere around the world as possible, and spinning up that server for the time it takes to achieve that task, that microservice, like I mentioned before. If it's distributing 130 versions of news, if it's transcoding a file, generating a playlist, anything like that, those small tasks that happen when you click a button or when you refresh a page, we basically rent that server for few seconds, a few milliseconds, up to 10 seconds, 30 seconds, however long it takes. And then when that task or that process is done, we hand that server right back and we pay for what we use. So that makes it very scalable, super cost effective. It's really fast because of the computing power. And that opens up a whole new world of possibilities that radio stations don't even have to directly deal with this. That's the beautiful thing, is that because it's a managed service, you just work in the web interface. All this happens fast for you and your staff because of AWS. And just to paint a better picture of what this looks like, there's sort of layers to it. So there's a region, and within that AWS region, there are multiple availability zones. And in each zone, there's up to 6 data centers. So let's just say Oregon is a region, because it actually is for AWS. US West 2 is what they call it. And that's based in Oregon. I don't know exactly where in Oregon. They keep that a closely guarded secret. But inside that region, there's multiple zones and multiple data centers in each region. So hypothetically, at any time, your data is duplicated and stored for maximum redundancy and security in multiple data centers in multiple regions. So you're looking at probably having 2 or 3 copies in West, 2 or 3 copies in East, and then absolute worst case, we have a sort of the same infrastructure in Europe and in Asia as well. But it really just goes to the robustness of a cloud infrastructure, how much more secure it is, and how many people at AWS are actually sitting in a room just concerned with security. It's something that's not necessarily possible for us on a small local level of radio. So it's just using that power of the cloud. So now we'll switch to AI. And this is we've all been using AI for years in different ways. And now I think it's about how do we incorporate it day to day in our radio workflows and our radio lives. Because if you ask me, the best way to use it is as an assistant. I'm sure some of you guys have played with ChatGPT. It's like a search engine on steroids, right? You can ask it for this, ask it to refine the search, data analysis. It's tremendous at. It's just a great time saver. But being a radio playout and automation system, we found there was also other ways to incorporate it using ChatGPT 4.0, Google Gemini, other large language models. We built an AI voice tracker. And I think the cool thing here is how automated it can be for a station. This is a perfect solution for any station that doesn't have an overnight shift or a late night weekend shift. If it's just music and sweepers, why not throw a voice in there to give your late night listeners just a weather update, news update, promote the morning show the next day, or any station community events that are coming up. And essentially all you have to do is pick the voice, pick the topic, and that's the only manual work you do. Every time the playlist is created, you get a script and you get the audio file, which the script is editable, but you can also not edit the script. You can just be as hands off as you want. So that's one way we've incorporated AI into the technology. Some of our clients have taken that and really run with it. And we have a cluster this one's in Germany, that does 15 stations. And a lot of these AI examples are going to be in Europe because it hasn't been adapted super well in the US yet. And the reason for that is that Europe is just more willing to adapt these new technologies than we are, some of them at least. So, this case study in Europe, in Germany, Radio Galaxy is a group of about 15 stations. 2 p.m. every Saturday, they run a 1 hour chart show. So, your typical, basically 15 song countdown to whatever the top song of the week was. But because it's 15 different markets, they have 15 different charts. Some of them overlap, but city by city, Munich, Berlin, Hamburg, Dresden, wherever it is, each program director sends, here are the top songs of the week, but then we cross reference that against the charts. And when I say we do that, we don't do anything manually. The AI cross references it with the Shazam charts or the Spotify charts, Apple Music, takes all of that and produces a 1 hour chart show, including swapping in from the station's audio libraries some of those top trending songs. So it's something that isn't possible without AI. This is an AI host. It's all pieced together by AI, but even manually trying to put together 15 different chart shows market by market, it's just not really feasible to do that because it takes a lot of time, but it saves you time when you do it with AI. Something that's been a part of our software since the very early days before people were even talking about AI. And this could be machine learning, like a subset of AI, but it's essentially automatic mixing and segues in the playlist. So that little graphic on the right, that's just local content or network content running over the ramp of a piece of music, fading into an imaging or a sweeper, and that's sort of what that example shows. But it's all mix point driven, but Radio Cloud learns and uses those AI to track what's the best mix point or the outro of a song if one is not set, and then if one is set, it just uses that to kind of smartly fade between elements. In Finland right now, there is a national FM station that didn't have an afternoon host. So they came to us. They said, can we do this with AI if we clone our program director's voice? Because he does a show on the weekend, but he doesn't have a weekday shift because he just doesn't have the time to do it. So he cloned his voice, or we assisted with that voice cloning. We don't do the cloning ourselves. We're working with third parties, 11 Labs, I'm sure everyone's heard of, Play HT, companies like that, that have great AI voice capabilities already. So he cloned his voice. We built that into just a 4 hour log, and they're running now a national 4 hour drive time show hosted and produced by AI. And it's gotten great reception from their local listeners because they're trying something new. They're trying to just learn themselves, how does AI sound? How can this play into our future day-to-day workflows? So all that's cool with the voice technology, but the way I see it being adapted more frequently and at least sooner is with it as an assistant. And this is actually something we're developing now. We call it Assistant AI. Essentially, you would log in and be able to see your playlist, trending songs, trending news stories in your market. And then whether you're doing the show live or voice tracked, you could select that specific talk break. Say if you want to, get a sports update, a weather update, kind of in the middle here. Just, yeah. Talk about the next song or the next artist, station promo, things like that. And then it'll generate a talk break for you. And essentially, it's just generating a paragraph of text. And this is something you could read verbatim if you want. More often, I would think this would give you a starting point to be creative, a starting point for your research so you don't have to go combing the internet for everything. So it's a time saver. It's a research assistant. It gives you these extra fun facts here. And then the way to sell it to your programmers and your hosts is, everyone has to write a blog post, right? That's sort of like the directive that seems like it's coming down these days. Social media posts, blog posts, multi-platform content. It's all right there for you. It generated a talk break within a matter of seconds. And even if you don't use that on air at all, there's your social media content or your blog post for the day. So It just makes everyone a little bit more efficient, not having to spend hours researching on the internet. The idea that I have too, which sort of came to me in the last week or two after I saw a presentation at a conference late last year. So ChatGPT is sort of open source. Everyone trains it and asks questions with the prompts that we feed into it. But you can actually train your own GPT, which is kind of cool too. And you just can plug in guidelines and prompts, upload supporting documents, that type of thing. And the real benefit to that is you can have a custom GPT for your organization, your job. The guy I saw do this in his presentation, he essentially fed all 20 years of his medical history into GPT. And I thought that was genius because now he, instead of going to WebMD when he feels sick, he can just go to this GPT and say, this is the symptoms I'm feeling based on my medical history, which you now understand because you're like my personal assistant, nurse, or doctor. What am I suffering from? What are the best treatment options? How do I avoid this type of thing in the future? And so it got me thinking, why couldn't we do that in radio, where as a station we could plug in on the programming side listener metrics, sales data, marketing campaigns, social media, anything like that, and figure out, where have we been losing out on sales, or when are our listener metrics most up? You build out this database of it, and then it's kind of there for you to reference as it gets smarter and smarter as you plug in more and more supporting documentation. And then when I was talking to the Seattle chapter yesterday, someone made a joke about I think an EMG truck that was no one knew how to bypass the alarm system on it when it was going off. So someone had to come in just to turn it off, just so they could drive the truck home from an on-site. And so that sort of plays into the last sentence, or the last point of the third bullet point there, which is, as engineers, what if we take some of that supporting documentation and just kind of put it into a GPT for our particular station? And I know something that's being talked about in the industry is, how do we get more young engineers interested? How do we get more people that are already in radio interested in the engineering side? And even if they're not fully trained engineers right from the jump, maybe having something like this in a easily accessible GPT where you can ask it questions, why do we do things this way? Or what happens if this box goes out? How do I get a quick replacement? Or how do I rewire this? Things that take a little time and a little supporting documentation and guiding to build out that database. But that type of stuff is possible with AI, which I think is really cool and really fascinating. So before we wrap up, I'll give you just a little look at the platform. So let me minimize this. Can you guys still see that virtual console?
Oh yeah.
Okay, perfect. So again, everything I'll show you today is browser based. So this is just me opening Google Chrome here in my home office and popping open whatever my radio station is. So this is our live studio. It is exactly that. It gives you the ability to broadcast live from wherever you are with just a laptop, a microphone, and an internet connection. And that's the minimum. Of course, it works great with a touchscreen. It works well with your big studio board. It also works great with smaller MIDI devices or MIDI consoles with motorized faders. And so it's a way to rethink, as engineers, as general managers, and the money people, when I need a new studio board, or when I need a new, remote equipment, essentially. Do I need to go invest in a big Wheatstone board, or an Axia, a Quasar, or one of those really nice consoles? And to be clear, we were the Telos dealer in Germany for 10 years before I joined the company. So we are fans of a nice looking studio with a big board. But this just gives you the option to think differently about it, because you don't necessarily have to have a big studio build out. You could take a touchscreen, put that in the studio with a few mics around it, a device to create a mix minus for those mics so everyone can hear each other, and you're off to the races. Easy to invite guests and co-hosts remotely, easy to hook up a SIPR and an IP phone hybrid to take and make calls directly in the browser. So that's the live side of Radio Cloud. The automation side, the playlist itself is built out either with you take like a music master or selector log, and then on the traffic side, like natural log or Marketron, take those and we merge them together and create a playlist. Or we do have an internal music scheduling system as well. But the playlist right here, everything that's purple is your imaging IDs, sweepers, jingles, green is music, and then yellow is commercials. Voice tracking done right into the web browser. Again, all you need, laptop and a microphone, and you can essentially just press record, do your voice track right into the browser. Auto trims both ends of it, but you can do some simple editing as well. So you can say, well, I don't want this first part. I'm going to cut that out. And then I need to boost the gain on this beginning part. And so as you do more of that, usually once or twice, this thing's super easy to use. We will set your voice track on the ramp of the next song. So tell your hosts and your programmers that they don't have to manually take the previous track and the upcoming track and move those. That's all automatically done. So it's a suite of tools that's built to make you more efficient, whatever your role is at the station. All audio is uploaded to the audio browser here, which is content management. It is essentially one of two ways. We give you an FTP folder at the beginning of a partnership. We would mirror all of your existing content. So music, imaging, commercials, you tell us the folders, we build them, you upload to them. It's all mirrored in the cloud, which is essentially just to say it's in an Amazon S3 bucket. But the cool thing is we take the extra security step of encrypting your data from Amazon Web Services. So they see that there are files stored, but they don't know what those files are, and they can't see that. It's just the station, and it's just Radio Cloud in case we need to help troubleshoot. All of that data is stored in the cloud. Metadata editor gives you the ability to, of course, adjust your intros and outros and mix points and all that kind of stuff, but also set up to 5 alternate mix points. And it's all down to the thousandth of a second. So it's very precise. All this is able to be done, in an instant right in the browser. And then in terms of actually building out the playlist, we just build broadcast clocks like this. Maybe you have one for your morning show, one for your music hours, one for syndicated show on the weekends, afternoon shows. Some stations we work with have one 24-hour clock and they just run music the whole time. And or one clock for every hour is a better way to phrase it. And then other stations have 20 or 25 different clocks running throughout the week. But it's all drag and drop, so it really makes it nice and simple for your programmers to actually build this and maintain it or edit it over time if necessary. Building with your imaging, your songs, any commercial breaks, local content being your voice tracks, and then, of course, if you're using it, which is totally optional, the AI voice tracker as well is where you can set your presets in there. So a very quick, I don't want to go too deep into it, but a very quick demo of what the software looks like, which I think it's just a different looking software than a lot of the play out automation systems today. And I don't think that's necessarily a bad thing, but I'll jump back into the deck here. And so I mentioned sustainability earlier, and I do want to spend a couple of minutes talking about that. And the easy thing to say and assume is, well, because I'm going to the cloud, I have less hardware, so that makes me more sustainable. And that's true. It's a little deeper than that, but on the surface level, that is true. If you don't have as much hardware on site, that means you're probably not outputting as much energy. Maybe your server rooms don't have to be cooled as much. So maybe your electric bills go down, your on-site maintenance decreases. So that makes you more sustainable and a little more scalable because, like I described, you're renting those servers from one of those AWS data centers in those regions and zones. So that all goes towards sustainability, but it's also, both sides are responsible for it. So when I found this chart, I love sharing this in any talk that I give because it painted it really clear for me, and I'm not an engineer and I'm not a sustainability engineer especially, but the customer, being a company like Radio Cloud, is responsible for sustainability in the cloud. So that meaning, how we design and deploy our software and our code, and just all of that is our focus. And then because we're taking that and running it or hosting it or taking advantage of an AWS infrastructure, AWS fits in this because they're responsible for the sustainability of the cloud, meaning those servers, the data centers, how it's all cooled, how it's built. And companies like that, AWS, they'll say they're going to be carbon neutral by whatever date in a few years into the future. And that's great because we get to take advantage of that, knowing that our infrastructure is running in something which is a sustainable infrastructure. And then as a result, over time, maybe a station can reduce its hardware footprint and become a little more sustainable that way too. So just to sum it up, and then we can dive into some a conversation, back and forth questions, whatever you guys, however you want to do it. Moving to a cloud-based operating system, there's four buzzwords I like to always say. So it gives you more reliability, flexibility, scalability, and of course, security. And that's on a global level because of the partnership with AWS, but also because the cloud is essentially, you can access it from anywhere. You get the ever evolving software that you wouldn't get by purchasing a terrestrial based playout system outright. So the metaphor comparison I like to use is, I drive a Camry. I love my Toyota Camry. But if Radio Cloud is like getting a new Camry, and then the Camry never ages. Like, it's always upgraded and outfitted with the latest features and improvements, and there's no wear and tear on it ever. So you always have the newest version, and you don't have to do anything on your side to get that. It just happens automatically. And then, like I mentioned, we were talking about the live studio and the virtual console. It introduces the possibility for downsizing hardware and studio space. Previously, of course, that was possible and doable, but it just wasn't quite as easy or doable as it is now with a cloud environment, and how you can really reduce the hardware footprint and have a lot of that running in the cloud. So I really appreciate your time today, guys. Thanks for listening. I'm craving some barbecue now as well, but let's talk questions. I'll leave this slide up as well. I think this just goes to our website, but that's my email, that's my phone number, and I'm here. So ask away and let me know what you think.
The question: do we have to come to the mic, Kent? Or
No, just speak up.
I have a question. Can you hear me okay?
I can hear you perfectly. Yep.
So one of my stations, how do you integrate 12-foot satellite dish feeds with cue triggers and spots uploading and downloading on an XDS or Wegener receiver?
Yeah, great question. So what we've done with our news talk stations currently, who run off of XDS, Wegener receivers, and that type of thing, the playout box I showed you, that will just sit wherever those receivers are, and we usually connect into those receivers. Sometimes we use like a Telos X node or something similar for the switching, but we can essentially receive all cues and triggers from satellite receivers in the cloud, and then have it switch from Radio Cloud playing out the local spots to going to segment one of whatever show is coming off the Wegener receiver, back and forth, even one receiver to another receiver. That's how we do it now. Is it's possible to do everything in the cloud, and depending on the receiver, I know Wegener is nice because a lot of the interface is live wire and audio over IP. That makes it nice and easy. But even with older style receivers, we can just with the right adapters into our box and or into an X node, the switching is definitely possible, and it's all able to be done in the cloud.
With cloud IP comes a whole connectivity problem for a lot of radio stations that don't have IP. We're relying on a cell hotspot.
And you don't need a huge amount of an internet connection to run Radio Cloud, especially if you lose internet, you stay on the air because that box stores your logs and your audio forward. And if it's satellite, I assume because all the switching is done locally, you also stay on the air that way. But I mean, we've had stations kind of with a very low, unreliable internet connection who, even if it goes out once in a while, the way we do it is the box is at the station or at the transmitter, and it's in constant contact with the actual cloud environment. So any new updates to the playlist, voice track, new commercials, songs, jingles, IDs, whatever it may be, every 5 to 10 seconds, the box looks at the playlist in the cloud and says, is there anything new I should pull down to this box? If it's yes, boom, it pulls it down. So that's, of course, not happening without internet. But even if the internet's going in and out, in and out, in and out, when it's in, all it needs is essentially 5 to 10 seconds to recheck the playlist to see what else is new. So that's sort of how we do it. You don't need a huge internet connection. 5G hotspot as a backup is not a bad thing to have. So.
All right.
Moved, did he?
Thank you.
Huh? Yeah.
Okay. Thanks, guys. Have a good one.